Welcome to this video on top Kafka interview questions for experienced professionals. In this video, we will explore 30 key questions with best answers and real-world examples to help you prepare for your next interview. Be sure to check out our channel Zito TechVerse for more. This video follows a structured roadmap, covering everything from Kafka core concepts and performance tuning to resilience, security, and advanced architecture patterns. Let's start with the basics. Kafka is a distributed commit log designed for high throughput. It decouples producers and consumers, allows for parallel processing via partitions, and ensures durability through replication. A common real-world use case is enabling multiple teams to consume the same event stream independently. Moving on to data flow, a topic is a named stream of records. Partitions provide the necessary parallelism, while offsets track a record's position within a partition. In an interview, always remember that an offset acts as a pointer for consumer progress. Next, let's discuss scaling. Consumers in a group share partitions, with each partition assigned to a single member. Any change in group membership triggers a rebalance. To minimize latency spikes during this process, consider using cooperative rebalancing. Delivery guarantees are crucial. You have at most once, at least once, and exactly once options. Exactly once is achieved using idempotent producers and transactional rights. Your choice depends on the specific balance required between business risk, latency, and cost. For partition design, use business keys to ensure events for a specific entity remain ordered. Avoid keys that lead to skews, where one partition gets overloaded. Always consider data cardinality and test your distribution before hitting production. On reliability, ACKs equal all ensures producers wait for acknowledgement from ISR replicas. When combined with idempotence, it effectively prevents data loss and duplicates, though it requires careful tuning of flight parameters to maintain ordering. The in-sync replica set, or ISR, is critical for fault tolerance. Setting a minimum number of in-sync replicas ensures that a write is only considered successful if a specific number of brokers are healthy, balancing durability against availability. Managing consumer lag is vital for operational health. Lag is the difference between the latest and committed offsets. Monitor this closely, and if sustained lag occurs, scale your consumers or increase your partition count. When comparing Kafka and RabbitMQ, remember, Kafka is built for high-throughput event streaming and data replay, while RabbitMQ excels at low-latency task queues and flexible routing. Choose your tool based on your system's core needs. Schema evolution is essential for maintaining contracts between producers and consumers. Using a schema registry allows you to enforce compatibility rules, preventing breaking changes. It's a key strategy for avoiding integration failures. Kafka transactions enable atomic writes across multiple partitions and topics, which is the backbone for exactly once processing in Kafka streams. Always be mindful of configuration and timeout settings when implementing this. Lastly, understand the difference between retention and compaction. Retention policy deletes old messages based on time or size, while compaction keeps the latest record for each key. Compacted topics are perfect for state snapshots. For low latency, focus on tuning linger.ms and batch size, optimizing your JVM and network settings, and avoiding heavy synchronous calls in your consumers. Most importantly, always monitor 99 latency for a true picture of performance. Let's move on to dead letter topics, or DLTs. DLTs are essential for reliability. They ensure that failed records are never silently dropped. By moving these records to a dedicated topic, you can preserve their metadata and error reasons, which enables targeted remediation and easy replay once the issue is resolved. Securing your Kafka cluster is a non-negotiable requirement for enterprise deployments. A robust security strategy must cover 3 pillars: authentication to verify identity, authorization, typically managed via access control lists, and encryption, using TLS to protect data in transit. Remember to audit access and rotate your credentials regularly. Kafka Streams is a powerful Java library for stateful stream processing. It supports operations like joins, windows, and aggregations, using RocksDB for efficient local state storage. It is the ideal choice when your business logic is natively streaming rather than batch-oriented, allowing for real-time materialized views. In Kafka Streams, windowing allows you to group events into logical time buckets. By using stream time, which relies on event timestamps rather than the local processing clock, you ensure accurate analysis. Grace periods are key to correctly handling late-arriving events in scenarios like fraud detection. KRaft mode marks a significant evolution in Kafka by removing the dependency on Zookeeper. In KRaft, Kafka brokers manage the metadata quorum internally, which simplifies operations and provides a clearer path to scalability. If you're designing modern deployments, planning for a KRaft-based architecture is a must. Effective production monitoring requires tracking broker health, under-replicated partitions, and consumer lag. You need to keep an eye on throughput, latency, and error rates. Utilizing tools like Prometheus and Grafana, combined with actionable service-level objective alerts, will allow for rapid mitigation of any production issues. MirrorMaker 2 is a vital tool for disaster recovery. It replicates topics across clusters or regions and supports various failover scenarios. By replicating offsets, it ensures a smoother transition during a failover, though you must carefully manage topic naming and ACL synchronization across your environments. For retry topics, adopt a structured approach with back-off delays. A common pattern is to move failed records through a sequence of retry topics before finally landing in a DLT. Always attach metadata to avoid infinite loops, and include error codes to gain analytical insights into why processes are failing. Avoid common anti-patterns that can cripple your cluster. Creating too many tiny partitions creates unnecessary overhead. Be wary of partition hotspots caused by poor key design, and always implement schema governance to avoid payload drift. Finally, never let consumers perform blocking I/O without proper isolation. Sizing your partition count requires careful capacity planning. You must estimate your target throughput and the necessary level of consumer parallelism, while also accounting for future growth. Remember, while too few partitions limit scaling, too many partitions can actually increase management overhead and rebalancing costs. When dealing with out-of-order events, remember that Kafka only guarantees order within a partition. For global reordering, you will need to use event time processing and sequence numbers. Designing your state transitions to be idempotent is the most reliable way to handle out-of-order arrival without corrupting your data. Back pressure occurs when your consumer cannot keep pace with the producer. You can manage this by pausing and resuming partition consumption, scaling your consumer group, or ensuring your processing logic is optimized. Using bounded thread pools and bulkheads ensures that a single slow downstream dependency doesn't crash your system. Migrating from database triggers to Kafka events should be a gradual, phased process. Start by implementing change data capture to publish reliable events. Use a dual-write approach, only with strong safety guardrails in place. And always validate your event completeness before finally decommissioning the old database triggers. When asked how Kafka compares to traditional ETL, emphasize that Kafka is a real-time streaming backbone, while traditional ETL is often periodic and batch-oriented. Kafka's strength lies in enabling immediate reaction to data, though in many modern platforms you will find both approaches coexisting for different use cases. Finally, for multi-tenancy, rely on topic namespaces and ACLs to enforce isolation. You can use quota management to ensure fairness between tenants. While a shared cluster is cost-effective, it requires strict governance. For regulatory or extreme security needs, dedicated clusters remain the standard approach. Let's tackle large messages in Kafka. The best approach is to avoid storing them directly in Kafka. Instead, store the payload in external object storage, and send only the reference in your message. If you must send large messages, tune the broker's max message bytes carefully, but prioritize compression to mitigate impact on memory and latency. For production readiness, ensure you have a robust checklist. This includes validating replication and ISR configurations, enabling schema compatibility checks, and setting up comprehensive alerts for lag and rebalances. Always test your runbooks and recovery plans with chaos scenarios to ensure you can handle unexpected failures. Thank you for watching this deep dive into Kafka interview questions. We hope this guide helps you in your professional journey. Don't forget to subscribe to Zito TechVerse for more expert insights and future guides to keep your skills sharp.